Since we've been away from proofs for a little while, I'm going to go ahead and video the 2 homework proofs for you. So this is 21 on 6.4 homework. So given A, B, and C, D are parallel. So I know that. Prove that DC over BC is equal to DE over BA. That is our proportions after we've proven the triangles similar. So now that I have a plan, I am going to go about how do I prove these guys similar. Well, I have my butterfly picture, which means that I have vertical angles. I also have parallel lines, which means I have those alternate interior angles. So I'm pretty sure I can prove these similar by angle, angle, side. So let's give it a try and see if it works. So AB is parallel to DC, and I've already marked that on my picture because we know how important that is. I'm going to go ahead and write my vertical angles. So DCE is equal to angle BCA by the vertical angle theorem. Now, remember I can do either set of vertical angles, but here is, or of alternate interior. Here are my parallel lines with either this as a transversal, which would make this one and this one equal, or this as my transversal, which would make that one and that one equal. I only need one set for my theorem, so I'm just going to go ahead and say that angle EDC is equal to angle ABC because parallel implies alternate interior angles. I now have enough information to say that my triangles are similar. So triangle CDCE is similar to triangle BCA, and that is by angle, angle similarity. Once I have that, then the proportion naturally follows. DC over BC is equal to DE over BA, and that is by definition of similar triangles. Just like CPCTC would follow right after a congruent statement, definition of similar triangles is how we are going to say those segments are proportionate. Now I'm going to go ahead and go down to 22 and work 22 for you. Now this one is going to go back to our quadrilateral chapter. If I am given a trapezoid, how and why does that help us? Well, trapezoids were defined as having one pair parallel sides. So I'm going to go ahead and say that BC is going to be parallel to AD by definition trapezoid, because they wouldn't give me information if I didn't need it. So I need to prove the triangle BEC is similar to triangle DEA. Well, which triangles are those? That's this triangle and this triangle. And as soon as I draw them and get rid of kind of visually the other stuff, I have a butterfly picture, which means that I have vertical angles. And really, this problem is just like the one before. So I'm going to say that angle BEC is equal to angle DEA by the vertical angle theorem. I have parallel lines, which means I have alternate interior angles. I can use either set. I can use, oops, I marked those. I can either use this one and that one, or that one and that one, but I only need one pair. So I'm going to go ahead and say that angle CBE is equal to angle ADE, and that is by parallel implies AIA. And I have enough information to say that triangle BEC is similar to triangle DEA.